Hey, good morning. How you doing? So, we're gonna do a quick video on stoichiometry, like a redox reaction. It'll be a really short. So I'm gonna share my screen and go ahead and get into it. And I realize I do not have my calculator over. I'm sitting on the couch. I don't have my calculator with me. That's okay. Share, share, share. Turn this TV off. Share here. I'm still sharing. Still sharing. Over there. All right. Sorry, I was not prepared with my calculator. Periodic table. Okay. So just, oh yeah, there's the practice problem. You already see it. I just need to get there. There we go. So it's just a stoichiometry problem that involves something called a redox reaction. And it's a little bit different than what you're used to. So I just kind of wanted to go over it. All right. Okay. So when 35 milliliters of a solution of 0.230 lithium perchlorate, okay, is added to acidified chloride ions, the chlorine produced reacted with 23.5 milliliters of potassium sulfate. Calculate the concentration of potassium sulfate given the equation below. Okay, so let's look at our equation below. I see perchlorate and chloride and hydrogen ions. Well, I do not see a lithium perchlorate. Well, as you know, that is because lithium is a group 1A metal, therefore it is a spectator ion. So what you see here is your net ionic equation. When you don't see the lithium present, he's the spectator ion. So he's been removed from the equation. So my lithium perchlorate is represented right here. Okay, without the lithium, excuse me. And I've got 35.0 milliliters of it. And it is a 0.230 molar solution. I then have information about potassium sulfate, which would be represented right here, okay, without the potassium, because potassium is also a group 1A alkali metal and is therefore a spectator ion. Okay, and I know that I have 23.5 milliliters of my sulfate ions. And my question is, what is the concentration? Whenever you're asked for the concentration, it means the molarity. What is the molarity? Okay. So we know that we need the moles of the potassium sulfate over the liters of the solution. And we already know that we've got 23.5 milliliters. So I know that I have 0.0235 liters. All I need to do is determine what those moles are. All right, well, this is just stoichiometry. It's just a little different because we have two equations. In any stoichiometry problem, we always start with what we're given. So I will start with my 35 milliliters. We know that there are 1,000 milliliters in every 1 liter. And according to my molarity, every 1 liter is 0.230 moles. It's time for a label. Moles of what? Moles of the perchlorate ion. Now, if I could go from moles of perchlorate to moles of chloride, and then I can go from moles of chloride to moles of the sulfate, and I will be able to get what I need. Okay. If you go to the top and you just read it real quick, it says that we have, it was added to acidified, hold on, let me undo that. We had acidified chloride ions. Well, here are the chloride ions. No, that's not the chloride. Here are the chloride ions. And this is your acidified here. The acidified is the presence of H. So we don't need all of that stuff, right? We don't need all of that. But I can once again, sorry for my tangent, go from the perchlorate to the chloride. So I will use my 1 mole of perchlorate to 3 moles of chloride, okay? Now I know that moles of chloride need to go on the bottom, and I will now use my second equation where I will go from the moles of chloride to the moles of the sulfate. So that is 1 mole of chloride to every 2 moles of the sulfate ion. And notice, okay, so we'll get an answer there. I hope I did that right. I've got 4.83 times 10 to the negative second moles of sulfate, right? And potassium sulfate and sulfate are in a 1-to-1 ratio. So therefore, I have 4.83 times 10 to the negative second moles of potassium sulfate. Make sure I did my math right. I encourage you to do the same thing because it's easy to make silly mistakes. All right, if I divide this by my volume, which I have right here, it's 0.025 liters, 0.0235 liters, I would get a concentration that is 2.06 molar of K2SO4, okay? 2.06 molar concentration. Easy. I'm out. Bye, y'all. Stop. And